Imagine you are a librarian in a vast library filled with books and authors. You have a magical tool, REST APIs, that helps you fetch any book or author details you need. But there is a catch. For every different piece of information, you need to cast a new spell, create a new API endpoint. Want all the books? Cast one spell. Need details of a single book? Cast another. And if you only need the book title, you either cast a new spell, create a new magical object like the DTO, or fetch the whole book and just use the title. This is like carrying an entire book when all you needed was a single page. A situation known as overfetching. Now imagine a new magic comes into play, a more powerful and efficient one, GraphQL. With GraphQL, you don't need multiple spells. You have a single magical incantation and you can specify exactly what you need, no more, no less. It's like having a magic wand that fetches just the page you need from a book, eliminating overfetching or underfetching. Moreover, GraphQL allows you to gather data from multiple sources very easily, like summoning books from different sections of the library all at once. It also includes or introduces a type system, a magical schema that describes your data, allowing you to specify exactly what you need. As we journey through this course, we'll be adding this GraphQL magic into our existing .NET application. But before we start casting spells, it's crucial to understand the components of a new magic: types, queries, and schema. Imagine you are a messenger in the kingdom of APIs, tasked with the transmitting data over the vast landscape of internet protocols such as HTTP. Now you have two horses at your disposal, REST and GraphQL. Both are loyal steeds that serve the same purpose, but their methods are as different as night and day. REST, the older of the two, is an architectural pattern. It's like a horse that knows multiple routes to various destinations. In a complex kingdom, you might have countless routes, one to fetch all the courses, another for all the books, yet another for book details, and so on. REST is a server driven architecture, meaning the server dictates the data you receive. However, this horse has its quirks. It can automatically remember routes, which is caching, and understands multiple dialects, which is data formats. It also uses HTTP status codes as signals to identify any hurdles or errors along the way. On the other hand, GraphQL, the younger horse, is a query language. It knows only one route, that is a single endpoint, but it's a magical one. You whisper to it exactly what you need, and it fetches just that. No more, no less. This eliminates the problem of carrying too much or too little information, known as overfetching or underfetching. GraphQL is a client driven architecture, meaning you, the messenger, dictate what you want. However, this young horse does. Imagine you are about to embark on a journey to build a GraphQL project. Before you set up, you need to familiarize yourself with the tools and maps available for your expedition. Your first stop is the Grand Library of GraphQL, located at graphql.org/code. This library houses numerous tools and services, each tailored to different programming languages. Whether you are a PHP adventurer, a Java explorer, or a C Sharp voyager like us, you will find the right tools for your journey. For our .NET API project, we'll be exploring ourselves with the GraphQL.NET and other libraries. Next, you venture into the open source projects realm. These are public territories where you can test your skills and gain a deeper understanding of how GraphQL works. Among these territories are the SpaceX API, the countries API, and the GitHub API. Each offers a unique landscape to explore. The SpaceX API, for instance, is like a cosmic observatory. Here, you can access a wealth of information about the company. You can query for the CEO, revealing Elon Musk, or request details about their fleet of dragons. Each query you execute is like sending a spacecraft on a mission, returning with the exact data you requested. The country's API, on the other hand, is like a global atlas. You can retrieve details for any country, such as its name, native language, capital, emoji, and currency. Want to know all the countries and their continents? Just craft the right query, and the atlas reveals the information. As you continue your journey, you will add GraphQL to your API project, enabling you to request only the data you need. It's like having a magical map that shows you exactly what you want to see. making your expedition more efficient and exciting. Before we dive into the depths of coding, let's take a moment to familiarize ourselves with the landscape of a project. Our project is a simple .NET API project, a small town with just a single API endpoint. The heart of this town is the courses controller, our only controller nestled within the courses folder. Venturing further, we discover the models folder, home to a class named course. This class or module is akin to a blueprint outlining the properties of a course, the ID, name, and description. Our journey then leads us to the courses repository, where we find a single repository, the courses repository. This repository, like a diligent librarian, retrieves all the courses from the database, fetches a single course using the ID, adds a new course, updates an existing course, and even removes a course from the database. Next, in the data folder, we find or we come across the application app DB context, where we have defined the DB context options and a single DB set named courses. Our journey also takes us past the app settings.json file, which holds the key to our database connection string. Our path then leads us to the program.cs, the grand gateway to our web API project. Here we have defined our controllers, the course repository, as well as the AppDB context. A special feature of our town is the Swagger, a tool added to visualize the API endpoints. It's like a map guiding us to the various API endpoints of our town offers. Now imagine pressing the play button to bring our town to life, and we will be redirected to our Swagger page. Now revealing five endpoints: get, put, post, and delete. Let us post a course ID 2, GraphQL, introduction to GraphQL, and execute. If you want to see all the courses, let us go to get courses, try it out, execute, and we'll see all the courses. If you want to see just one course by a ID, just type in the ID, execute, and we'll get the course. Now imagine wanting to get just the name or the description of a course. You would have to either create a new API endpoint or create a new DTO class and use that class with an automapper to get these values. And this is exactly where GraphQL comes in handy. By defining a type, a query, and a schema, you can request any property you want to get. And that, my friends, is the story of our .NET Web API project. A tale of how we navigate the landscape of our project, adding and retrieving courses, and how GraphQL can make our journey much more efficient. Having already explored the terrain of GraphQL and the Web API project, it's time to roll up our sleeves and delve into the heart of the project. Our first task is to gather our tools, the necessary NuGet packages. Let's head over to the NuGet gallery. So it's like opening a treasure chest filled with tools waiting to be discovered. We will begin our search for the first tool, which is the GraphQL version 7.8. Let's install it. To confirm, let's open the CS proj file, and yes, it is installed. Let's close it. The next one is GraphQL BI. It will give us the ability to add GraphQL into the program CS file. Let's wait for it to install. It's installed. Let's add it. Below the controllers, add GraphQL. Builder services, add GraphQL. Add GraphQL. Now you'll see a squiggly which says an error. To resolve it, we will first install GraphQL system text JSON and install the 7.8 version. Let's wait for it to get installed. Once done, let's c imply c dot add system text JSON. So we have added GraphQL into the project. Next, we will add a GraphQL library. Let's search for GraphQL 7.7. Let's install. Once done, let's add app.map graph IQL. Once this is done, let's open the GraphQL transports 7.7 install. Let's wait for it to get installed. Here it is. Now let's add app.map GraphQL ASP.NET. app.graphql. Now here we will add a schema class. For now we have not added it, so let's comment it out. And it is done. Now with our tools gathered, it's like looking at a map showing us all the tools covered. Right, so we have GraphQL, Microsoft DI, .NET Core, GraphQL, Energy Framework Core, SQLite, ASP.NET Core. So with all the changes saved, we have completed this part of our adventure. The stage is set for the next chapter, where we'll create a schema class and bring our GraphQL setup to life. Next, we have a quiz which cover all the details that we discussed in this section. Go ahead and try to attempt it.